Hey everyone, in this video we're going to be tying together some of the last few concepts and we're going to be actually solving an entire polynomial using synthetic division and using some factoring techniques. So to begin, let's go ahead and just look at the type of problem that we're going to solve first of all. So for example, in this question, we're given a function and we're told one of the factors. We're told that x plus 5 is a factor of this function. We're asked to then find all of the other zeros algebraically. So how we're going to go about doing this, we've got a few steps here. The first thing that we're going to do is do synthetic division with the zero that it gives us. So with the factor that it gives us, we change the sign of it, make it a 0, and do synthetic division. When we're finished with our synthetic division, we're going to get those coefficients at the bottom. The remainder should be 0. Make a note of that. Note, remainder should be 0 if we did it right. If you don't get a remainder of 0, that means you didn't do it right because we're told that this thing is a factor. So with our remaining coefficients, we're going to write a new equation. Remember when you do that you also have to subtract 1 from the exponent, the original exponent, the highest original exponent, we subtract 1. And then we're going to take that new equation and we're actually going to factor it. And then after we factor it, we're just going to set each one of those factors equal to 0 and solve it. So let's go ahead and dive in and do some of these. With our first one here, the first thing we need to do is always just double check and make sure we haven't skipped any powers in the function. All of these, there shouldn't be any that are skipped, but just going to double check. We got 3, 2, 1, and then no power. So we're going to write out those coefficients. So we got 1, 9, 23, 15. Make our box. And on the outside, it's going to be the opposite of this factor, so it's going to be -5. And then what we're going to do, bring down the first term, 1, multiply that, we get -5. Add them together, we get 4. -5 times 4 is -20. Add them together, we get 3. -5 times 3 is -15. Add them together, and we do get 0. So perfect, we got a remainder of 0. That's what we're looking for. So then we're going to take these remaining coefficients and write out a new polynomial. Since our highest power to begin with was a third power, we're going to start with a second power. So it's going to be 1x squared, or just x squared, plus 4x plus 3. So think of it just like we just have a quadratic, and we need to factor this then. That was our next step, was to factor it. So this is where we think what multiplies to give you the c, the 3, and then adds to give you 4. We do our 2 sets of parentheses here. This is like the opposite of foiling, kind of unfoiling. Put an x and an x. The two numbers that are going to multiply to give us 3 are 1 and 3. If they're both positive, we add them, we get 4. So that should be good. And then we solve this by setting each of these equal to 0, which is just going to give us the opposite sign. So x equals -1 and x equals -3. And then we also had from the original one, x equals -5. When we solved that one, x plus 5 equals 0. We get x equals -5. So those are our 3 zeros. And so we're just going to type those in. You're just going to use this plus symbol to add 2 more blanks. I believe you just type in the numbers. Double check that here. There we go. Yep. So let's go ahead and try another one. So we're given the equation, 3, 2, 1, no power, so good. Let's write this out. 1, -4, -25, and 28. Now this one looks a little bit different. Instead of giving us a factor, it says f of 7 equals 0. This means that 7 is a 0. Because f of 7 gives us 0. So 7 is just going to be the number outside here. We don't do the opposite because it's not written as a factor. It's saying that the 0 is 7. So then we can go ahead and do our synthetic division. Bring it down, 1, 7, 7. Add them, we get 3. Boom, 7 is 21. Add them negative 4. 7 and negative 4 is negative 28. Add them to get 0, which is what we're looking for. We then want to start with a second power because the biggest power in our original was the third power. So we get 1x squared plus 3x minus 4. And really, I guess what we could do is just set that equal to 0. I didn't do it on the last one, but you can do that if you like. And then we need to factor this. It's another pretty easy one to factor. What numbers multiply to give you negative 4 and add to give you positive 3? That's going to be x plus 4 and x minus 1. So when we solve those, we get negative 4 and positive 1 to go along with the original x equals 7 is a 0 as well. So we type those 3 in. Just don't forget the one that they give you. You have to also type that one in as well. And all right, and let's try another one. I guess those are the only two forms you'll see. The is a factor or the f of whatever is a 0. Well, let's just do this last one here. So we'll write out our coefficients. We do have 3, 2, 1, 0 for the powers. So we're good. 1, negative 4, negative 25, and 28. On the outside, we should have a positive 7 because it's a factor. So with the opposite, we're going to get 1, 7, 7, 3, 21, negative 4, negative 28. So we do get 0. It's good. Our new equation becomes 1x squared plus 3x minus 4. Factor this. We want numbers that multiply to give you negative 4 and add to give you 3. These so far have been super easy factoring ones. This one's going to be a positive 4 minus 1. So we get negative 4, positive 1, and the original one we had, which was the 7. So type those in. Maybe we'll do one more that you could do on your own for good measure. We could try a little bit harder factoring. All right, go ahead and try this one real quick. So for this one, write out our synthetic division here. 1, 3, negative 6, negative 8. On the outside, we should have negative 4. We don't switch it because it's saying that negative 4 is a 0. So be careful. If you switched it, then you probably would not get a remainder of 0. 1, negative 4, negative 1, 4, negative 2, 8, and 0. All right. It's good. We got 1x squared minus 1x minus 2. That factors into x minus 2 and x plus 1. So we get positive 2, negative 1, and then the original negative 4 as our solutions. All right, so that's all there is to it. Let me know if you are struggling in any way, and good luck, guys.